I'm going to share to you one of the questions that I usually encounter when I compete for math quiz piece or for some elevated folks, Math Olympiad. So, I had my experience in joining math competitions when I was in high school and continuously into college. Well, of course, when I was in high school, I was not that good, but through time, it improved. All because I had some training to do so and better understanding over some parts of math. Okay, to give you an example, here is one of the questions. So can you simplify, you have 1 over 2 squared, you have 1 minus 1 over 3 squared, 1 minus 1 over 4 squared, up to 1 minus 1 over 2023 squared. All over 1 minus 1 half, 1 minus 1 third, 1 minus 1 fourth, up to 1 minus 2023. Now, it seems that it has a pattern involved here. That's why they have this ellipsis here. So, it is continuously going up to 5 squared, 6 squared, 7 squared, and so on, until it reaches to 2023 squared. Similarly, over the bottom, it goes with the same pattern, only without the squared. So, what could be the hidden codes in this problem? Okay, one of the things that is a little obvious here is on top, because I recognize the pattern somewhere in algebra when it is involving factoring. Factoring what? Okay, so if you are within grade 7 or something, you may encounter this factoring method. We have this called difference of two squares. Okay, so this is basically a factoring technique uh, in such a way that we can simplify that into two different factors. How come? Because the difference of two squares has this kind of pattern. Like if I have a squared minus b squared, the factored form for this one will be two pairs of parentheses. One carries a positive and one carries the negative. And they have the same two terms. I mean, this pattern itself doesn't just apply to x's and y's, or, well, technically, the patterns in algebra. Even numbers follow this rule. After all, this thing is actually an identity. So, if I have, for example, 1 minus 1 half raised to 2, or 1 over 2 squared, I could factor this as 1 plus 1 half, and then I have 1 minus 1 half. Oh, so that's how it's going on here. Okay, so if I factor this up, you will have these two factors. And same thing with the 3 squared, the 4 squared, and the 2023 squared. So, since everything is in multiplication, and we have these Sasha factors at the bottom, all of the factors with 1 minus 1 over something will be cancelled out. Because of that, this expression will be reduced to 1 plus 1 half times 1 plus 1 third times 1 plus 1 fourth times 1 plus 1 over 2023. Okay, so I guess the hard part is over. So we already have these as your remaining factors. But what do we do with it? Okay. So let's take at least 2 of the samples in order to recognize the pattern. So say for instance I have 1 plus 1 half. If you are familiar with adding a whole number to a fraction, this is just similar to doing this in a mixed number. How come? The rule here is if you're going to add these, you have to make sure that the denominators are the same before you add the numerators. But in this case, 1 is adjustable. Okay? 1 can be turned to 2 over 2, 3 over 3, 4 over 4, and so on. But if you recognize how to convert mixed number to improper fractions, it goes with the same pattern. So if I have 1 plus 1 half, I could do 2 times 1, which is 2, then plus 1, that will be 3. So 1 and a half is actually 3 over 2. And then, if I go with 1 and 1/3, that will be 3 times 1 will be 3, plus 1 that will be 4. So that will be 4 over 3. And then the next one, that will be, if I'm not mistaken, if I get the pattern, that will be 5 over 4. Until it gets to 2024 over 2023. Now, do you see where it's going on here? Okay, since this is multiplication of fractions, you know that cancellation works, right? So in that case, the numerator here will be cancelled with the denominator here. So is 4, so is 5, so as up to 2023, up to 2023. So this one will be cancelled out too. Okay? So this technique is what we call telescoping. So since everything in the middle is cancelled out, all that remains is the numerator at the end and the denominator at the beginning. So this is basically 2024 divided by 2. Ingenious, right? So if we're going to simplify this further, since 2024 is an even number, so we can divide this by 2. So the final answer will be 1012. Try this one yourselves. And since you've already seen the technique, try to find some similar problems having telescoping as a technique. Till then, this is Megavinx, signing off.